Hello, thank you for joining us for this review of the PerkinElmer Spectrum 10 software. My name is Ryan Smith. I'm the Field Applications Scientist for the FTIR products in the Midwestern United States. If you have the Spectrum 10 software loaded on a PC, you will see an icon appearing similar to the Spectrum icon shown on the desktop. Double-click this icon to open the software. When the software is open, you will be presented with a splash screen and a login. Notice that no password field is shown here because of the settings that I use on the software on this particular PC. Here we're presented with options for connection to different instruments. If you have multiple instruments connected to this PC, you can click them from the drop-down menu, or you can select the Work Offline option, which is useful in situations where data analysis is performed away from the point of use of the actual instrument. This menu also shows instrument status and connection. Here's the typical user interface of the Spectrum 10 software. Each of the sections in the software can be minimized or restored using the dark blue handles. At the bottom here we have our parameters section. On the right hand side we have our setup menus, and on the left hand side we have the Data Explorer. The Data Explorer allows us to organize spectral data within folders called sample views. Also, these sections can be resized to allow visualization of spectral data or visualization of different parameters that are available in the menus. Also, across the top you'll see toolbars. These toolbars are customizable in their layout and sizing of different fields. Also, we see an icon which represents the accessory, which is mounted in the instrument. The content of the toolbars can be customized by clicking the downward-facing triangle. Items to be added to the toolbars may be selected from these menus, which are categorized for ease of addition. To add a function to the toolbar, left-click and drag the name from the command list to the toolbar. As an example, we will add scan type to the toolbar. Note that these objects may also be resized once added to the toolbar. To remove an item from the toolbar, left-click and drag it from the toolbar back to the menu. To change settings for login to the software, go to Setup Administration, as shown here. Each login may be added as a member of different groups. In the standard version of the software, users may be members of administrator groups or user groups. These will define the permissions associated with each group. In the enhanced security version of the software, there's more flexibility and different groups available for logins. Notice that the password settings are also customizable. The Windows Login option allows users to draw login information from the Windows operating system on the instrument PC. Alternatively, the software also allows users to log in without use of any password. If multiple instruments are connected to the software may be set to automatically connect to a default instrument, Or if the users prefer to be presented with a work offline option as shown at startup of software, this option here, Enable Auto Connect, may be deselected. To connect to new instruments or remove existing connections, Add Instrument and Remove Instrument may also be used. The Select Instrument menu allows users to go from online mode to offline mode. And the icons in the lower right-hand corner of the software will indicate connection status, current user, instrument status, and any maintenance tasks which may be required. Also, JSTOP size is shown. The Data Explorer at the left-hand side allows users to organize spectral data. Data may be copied from one sample view to another. To create a new sample view, we will go to File, New. To copy a spectrum from one sample view to another, simply left-click and drag from one sample view to another. To duplicate the entire contents of a sample view, left-click and drag the sample view name from one to another. To delete a sample view, select the sample view name and press the Delete key, or right-click and select Delete. Sample views may also be renamed so that spectral data can be organized and labeled appropriately. Moving on to the Setup menu options, our first stop is Instrument Setup. You'll notice that when we click the buttons on the right-hand side, the content of the parameter section changes. Under Setup Instrument Basic here, we see a variety of settings. These settings will change measurement settings of the instrument as well as the settings of the spectral data which is actually saved to the hardware. At bottom we have the number of accumulations, which is the number of scans which are averaged, resolution, start and end of the saved spectrum, as well as the abscissa and ordinate units. Down below we also see parameters which are specific to the accessory mounted in the instrument. Instrument settings may also be saved to instrument setup files for duplication of experimental methods between multiple instruments, as well as incorporation into macros. The current measurement settings may be saved by clicking the Save Current Settings button, and then by clicking the Export button, a setup file may be generated. The Advanced Instrument Setup menu contains other parameters. To the right side, we see quality checks. These are simple green, yellow, red indicators which can help untrained users determine whether or not a quality spectrum has been measured. The thresholds for these are adjustable and may be changed to fit the particular sampling method which is in use. At the left-hand side, we have atmospheric vapor correction, as well as other parameters. The toolbox has various maintenance tasks incorporated. The options shown here will change slightly depending on the connected instrument. Several of these tasks here, replace source, replace windows, and replace desiccant, will open wizards which walk users through maintenance tasks, showing prompts and photos guiding them through the process. To the left now we go to the Setup Instrument Beam Path menu. This shows the current state of the instrument, which is especially useful for instruments connected to microscopes or multi-range instruments such as a mid-near frontier. This menu allows you to change the measurement range of the system as well as diverting the infrared beam path to an external detector. Here we also have control over J-stop size, filter wheel position as equipped, and counters which are associated with maintenance and desiccant change. Again, these are counters which can be reset. If a message is produced relating to these counters, it does not necessarily indicate an issue with the instrument. To the left, we come across the Instrument Data Collection menu. This menu is used to determine where spectral data will be saved. To the left, we have background options, which dictate how frequently a background measurement must be performed. When this checkbox is marked, spectral data will automatically be saved to the directory below. Note that this spectral data is only saved on acquisition, not after processing. Also, by checking the Export button, spectral data may be automatically exported in any number of formats to a directory as specified. To the left, we have the Setup Instrument Auto Name menu. This allows users to come up with a naming convention. By default, the user ID and a counter is applied. You'll see that this is shown in the sample ID field up above. Both sample ID and description may be changed on a sample-by-sample basis. When running large numbers of samples, it may be useful to set an auto-naming convention which applies to the range of samples which will be run. Note that the sample table may also be used to predefine sample names which are to be tested. This is especially useful in routine QA/QC settings where a known number of samples of specific sample names will need to be run on a regular basis. Each time a sample is run, the sample ID and description will automatically change to the next entry in the sample table. Next, we move to the Laboratory Scheduler menu. This allows users to schedule prompts to perform various tasks with the system, including component checks, ready checks, instrument verification, and AVI calibration as equipped. Power save options are also available when connected to a Spectrum 2 instrument. Next, let's move to the ready checks. Ready checks offer a series of automated checks which may be used to check the condition of the instrument hardware as well as the sampling accessory. The ready checks may be run by clicking Measurement, Instrument Checks, Ready Checks, and Run selected to run all of those checked in the Setup menu, or they may be run individually from the list. These checks may be performed using an internal APV filter wheel as equipped, or by inserting standards manually into the transmission slide holder in the sample area. Reports will be generated as a result of the ready checks. These can be shown and printed automatically. Spectral data as well as logged results will be stored in the directory specified below. The abscissa check performs a measurement with polystyrene, checking the position of several known peaks across the spectrum. The thresholds here in the software are adjustable. These thresholds should only be changed after the ready check has been run several times under a wide range of conditions. This historical data will provide a guideline as to what thresholds are appropriate for the measurement. The noise check measures noise across a specified range of the spectrum. The throughput check and contamination check will compare a measured spectrum to a specified reference spectrum, which will represent the instrument and sampling accessory in good, clean condition. Y values are measured as part of the throughput check in ranges where very few materials will absorb or absorb strongly, whereas the contamination check spectral ranges are specified based on ranges where many materials will absorb and will absorb with modest intensity. Results from the checks are stored in this directory when the checkbox is marked. Results can be overwritten or appended. Instrument verification resembles the ready checks. However, instrument verification is designed more as a check of the FTIR itself rather than the sampling accessory. As a result, these checks also incorporate an abscissa check. The thresholds for pass or fail on these checks are also adjustable. However, like the ready checks, we recommend that these checks be run under a wide range of conditions before adjusting thresholds. The ordinate check provides a measurement of y-axis consistency of the instrument and is designed to be tested with an NG11 glass standard. A noise check is also incorporated as part of the instrument verification checks. The ASTM Level 0 checks may be performed with appropriate reference spectra measured with polystyrene. As with ready checks, these checks may also be run as a battery of tests or run individually from the measurement drop-down menu. The measurement position may also be specified within this menu. The Export and Email menu allows users to customize the output format of exported spectral data. This allows users to tailor spectral data files to be compatible with a variety of third-party software packages for data analysis. The peak detection algorithm may be adjusted in its sensitivity using the peak detection menu. The number of peaks labeled and reported may be adjusted using the settings at the right-hand side or by adjusting the sensitivity thresholds. The appearance of the software may be changed using the Setup View menus. The order and appearance of colors may be changed in the event that a display or a printer cannot accurately capture the color of a spectrum. The font sizes and appearance of graphs may also be changed. Path length setup may be used in situations where transmission measurements are performed, whether using a liquid cell or solid samples. This information is captured alongside the spectrum and may be determined manually or using a variety of methods in the software. If the FTIR is to be used for quantitative measurements and quantitative methods have been calibrated, these method files may be referenced for operation in the Spectrum 10 software. Method files may be referenced by clicking Add, and then browsing to the directory containing the quantitative method file. Once a quant method file has been specified, it will appear on the list. To perform a prediction, click the Run button. The prediction will be performed on any spectrum indicated with the dark blue arrow. To perform predictions against a single spectrum, click the name of that spectrum. You'll notice that the arrow is shown only next to that one spectrum. To select multiple spectra, hold down Shift and left-click. To select individually, hold Control and left-click. Or to select all, click off of the text. Quantitative results and diagnostics can be logged in this directory. These results can be overwritten or appended. Diagnostic values can be selected from the list, shown in this tab. Some of the diagnostic values shown are associated with the Quant Algorithms add-on pack. FTIR instruments are routinely used as a means for identifying materials. This is oftentimes performed through calculation of a correlation coefficient. The compare algorithm provides a means for this determination, reporting a value ranging between 0 and 1, 1 representing an ideal match only observed when a spectrum is compared against itself, or 0 when a spectrum is compared against a flat line. Real-world values will range between 0 and 1, depending on degree of similarity between the measured spectra. Reference spectra may be specified one at a time or by indicating an entire directory containing reference spectral data. Correlation thresholds may also be set within this menu. The discrimination option also allows users to discriminate between different materials. The nearest match must be, in this case, more than 0.05 different from the next sample to be positively identified. Note that these thresholds can be changed. The software default is 0.98. The discrimination value may also be changed. The performance of the compare algorithm may also be tuned by selecting or deselecting a variety of filters based on the sampling technique which is to be used or the sample type which is to be analyzed. Note that the number of results which are output as a result of the comparison may also be adjusted here. The range for comparison may also be changed to exclude ranges of the spectrum which are not informative or to account for changes in hardware over time. Use overlap region will use the common range between the two spectra. Comparison results may also be logged. By checking this box, a results file is created which may be appended or overwritten with each subsequent comparison. Library searches are oftentimes used as a sort of dragnet approach to the problem of material identification when working with unknown samples. To add a new spectral library database, click Add and Library Files. This allows you to specify a spectral library database in a number of formats, including PerkinElmer OEM formats, as well as Sadler and Thermo library formats. Alternatively, users have the ability to create custom spectral libraries. These sorts of libraries are oftentimes even more useful than third-party libraries, as they can be constructed with data which is known to be of high quality and relevant materials. When a directory is added, it will appear in the list. Oftentimes it is useful to view the contents of a spectral library database. To view the contents, click the library, then click the Details button. From here we can view the names of all the spectra in the library database. Spectra from the library database may be moved to a sample view by left-clicking the icon and clicking and dragging to the sample view. We now see it in the list. It's important to note that these spectra may not be processed due to the copyright protection. To view the spectral data in a list format, click the Administer button. Here we see a list of all the spectra, as well as a display of the spectral data. The contents of custom libraries may be updated by clicking the Update button. This will resync the contents of the library database file with the contents of the Windows directory, removing spectra which have been deleted from the directory as well as adding new spectral data. The spectral range to be searched may be restricted to leave out regions of the spectrum which are known to be uninformative. Results of the spectral library search can also be logged. Multi-search is an optional software add-on pack which allows users to search unknown spectra against combinations of library spectra. As many as 10 spectra can be added together by the algorithm for comparison to the unknown spectrum. The number of materials suspected to be present in the sample may also be adjusted by the user. Equations can be used to perform simple mathematical calculations using spectral data. Values like peak height, peak position, peak area, and other parameters may be calculated. Equations can be exported to a file for transfer and deployment to other systems and other PCs. To create a new equation, click Add, New Equation. Here a list is available containing the different equation options which are available. Conditional formatting may also be applied to results. When an equation is created, it will appear in the list. To remove an equation, select it and click the Remove button. To create a standalone file, select the equation and click the Export button. Macros allow users to chain together several processes to be run in an automated fashion on spectral data. Like equations, these will appear in a list. Macros can be added by clicking the Add button and selecting New Macro. This opens a new window in which users can choose from any number of steps to add to the macro. Instrument setup and data collection can be added to the macro to walk users through the data acquisition process. If the macro will simply be used to process existing spectral data, processes may be chosen from the list below. Library searches and comparisons may also be incorporated into the macro operation. Quantitative methods and equations may be linked together as well. Reporting and output allows users to generate a report automatically with the macro. Conditional flow will change the flow of execution of parameters in the macro depending on calculated values. Steps which are specific to the Spectrum Touch macro software add-on pack may also be added using the options at the bottom of this menu. To export a macro to a standalone file for deployment, select the macro and then click the Export button. To modify the settings of an existing macro, click the Settings button. Now let's go through a quick example of material analysis using the Spectrum 2 FTIR controlled by the Spectrum 10 software. First, we'll add our sample ID in the field at the top toolbar. Next, we will change the sample description. Next, we click the background button. Let's put this spectrum in a new sample view. To do this, we click File, New, and we're presented with an empty sample view. Next, we will determine whether the ATR was clean during the background measurement, utilizing the preview function. We hit Scan and are presented with the preview screen, which is a real-time measurement of the infrared spectrum. At this point, we can clean the ATR crystal. If the crystal was dirty during background measurement, peaks will appear above the spectral baseline, or above 100% transmittance. Here we see peaks extending above 100% transmittance. This tells us that the ATR was not clean during background measurement. To exit out of the preview, we can press the Halt button. At this point, we want to repeat the background measurement. Now we're ready to measure the sample by pressing the Scan button. We introduce the sample to the ATR using the clamp. As force is applied, we see the force gauge increase, and spectral features of the sample start to appear. When a satisfactory spectrum is displayed, we can press Scan again to go from preview mode to saving the spectrum. Now that we have a sample spectrum, we can prepare to use a library search to identify the material. I've gone through the list of spectral library databases, unchecking spectral libraries which are not relevant given the material type that I have tested. For example, some of these library databases contain vapor phase spectra of different solvents or other materials. Given what we know about the sample, we can very quickly and easily rule out other spectral library databases for the search. Here we see that the top search result is polypropylene, which is reasonable given the material type that we have analyzed as well as the overlay of spectral features.
Another useful resource, the help documentation. Topics can be searched within the help file to cover a wide range of topics. A PDF version of the user's guide is also available at this link. Additionally, the software has animated tutorials built in which show the software interface.
These animations cover a wide range of topics, including some shown in this recording. The animations include message boxes, as well as colored boxes to highlight areas of interest in the software interface. Playback can also be controlled using the control panel in the lower left. To exit, click the X.
All right, thanks Ryan very much. That was a great presentation here. Let us get to some of the questions that we have so far. Ryan, can you hear me though?
Yes, I can. Can you hear me?
Yeah, I can hear you. All right. So we have a question coming in. Can you edit the description after a sample has been analyzed?
You can, yes. So to change the description of a spectrum after it has been measured, you will want to right-click on that particular spectrum, and you can do this either viewing that spectrum individually or from within the samples view section of the Data Explorer. Once you right-click on the spectrum itself, you should see an option in the drop-down menu which appears, and you would click Status. There's a this will bring up a new menu, the Status menu, which allows you to modify the description associated with that sample spectrum. And you can also, from within the status menu, you can also view a variety of parameters associated with that spectrum including the spectral averaging, spectral resolution, the scan range, the ordinate units, many instrument details, as well as the history of that particular spectrum.
All right, thank you. So question, can I have multiple FTIR instruments connected to the same PC?
You can have multiple FTIR instruments connected to the same PC, but the way that this is done depends on which FTIRs you connect and the hardware configuration of your PC. If you want to have multiple FTIRs connected by Ethernet, then you will need to have a unique network card for each of those FTIRs. And it's also important to note that the software will only control one instrument at a time. So if you have 4 FTIRs for some reason on a single PC, you will only be able to use one at a time in the software. You can't have spectral acquisition running on 4 of them simultaneously.
All right, thanks, Ryan. There's a question, can I back up the software?
So the software doesn't have a built-in backup feature, but the instrumentation ships from the factory with a copy of the software. So we always recommend that our customers keep that software. Should anything happen to the PC, then the software can be reinstalled.
All right. So question, how can I correct the baseline of the measured spectra?
The process drop-down menu at the top of the Spectrum software contains a variety of processes which can be run on spectral data that have been measured. So there are a few options which provide baseline correction functionality. One is the data tune-up function, which I usually actually try to steer people away from. It's more of a data beautification process than anything else. The iBaseline process, as it is called, allows users to specifically pick baseline points for correction across the spectrum. This is the approach that I typically recommend to customers so that they know that they are picking points in the spectrum which are most appropriate based on their samples.
All right. There's a question from Amit. Can you disable the override function in the software?
I think we would need a little more information relating to that question. If this is overwrite, the override option, which is available in the processes, the Spectrum 10 enhanced security software for each workspace contains a recycle bin, which will capture spectral data if a user decides to delete or overwrite that, and also those actions are captured in the audit trail. The standard version of the software does not capture an audit trail associated with changes that are made.
Got it. Thanks, Ryan. There's a question, can you change the number of decimal places in peak ID?
You can change the number of decimal places, and that used to be a core functionality of the software. It is currently actually a standalone application. You can find that application under the hard drive actually containing the Spectrum software. If you navigate to the program files directory or program files x86, from that directory then to the PerkinElmer directory, then to service IR, then to bin, and within the bin folder there should be an executable program which is called decimalconfig.exe. That will open an interface which allows you to change the number of decimal points which show on peak labels.
All right, there's a question on, can you comment when should I use a Kubelka-Monk function or a Kramer's chronic transforms?
Yeah, so those are processes, those are also available within the process drop-down menu. And the Kubelka-Monk process is intended for correction of spectral data which has been measured using the diffuse reflectance sampling technique in the mid-infrared spectral range, whereas the Kramers-Kronig function is more applicable to spectral data which is acquired using a specular reflectance sampling technique.
All right, thank you. There's a question, can the software be interfaced to a LIMS system?
The software can be configured to work with a LIMS system. Now, the software itself provides a means for outputting compare results and quantitative results into CSV files. So the LIMS system would need to be configured to read that CSV file and pull the results of interest from that result file.
Got it. What is deconvolution function used for in the software?
So spectral deconvolution, and maybe we should, I guess, clarify what that is. So that is Fourier self-deconvolution, which applies to the spectrum. And this is a process which was historically used to artificially narrow the width of spectral bands in spectral data. And so it was used to determine whether a measured spectral band was a single unique spectral peak, or if it was actually two closely spaced overlapped spectral peaks. And so the deconvolution process would be used to sharpen features, clarify that, and then make a determination as to also peak position for each of the unique bands which are identified. Now that process should be used with care because the deconvolution parameter which sharpens the spectral data will also adversely affect what you might consider to be the signal to noise ratio of the measurement, in that it will actually introduce spectral artifacts. So there's also, as a part of that process, there's a smoothing parameter. These two parameters then, there's a lot of trial and error in terms of determining which parameter settings are most appropriate for your sample, but this will depend on a wide range of factors.
Thank you, Ryan. This is a very fundamental question. Do I need to use ATR correction to process my data?
So this all depends on how that data is to be used. If you want to use that data to search, if that sample spectrum represents a spectrum of an unknown material, and you want to search spectral libraries which contain spectral data measured in transmission mode, then you would want to employ the ATR correction process to make the measured ATR spectrum more closely resemble a transmission mode spectrum. Otherwise, if you are searching an ATR spectrum against an ATR library, then there is no need to run that process. Also, if you are performing quantitative analysis, all of the spectra which you have incorporated in the calibration, as well as those which you intend to measure after the fact, should be processed in the same manner. And so if you are measuring spectra with ATR for calibration samples, then you would simply employ the same processing method, whether you do or do not employ the ATR correction. In this particular instance, it doesn't matter so long as you employ the same approach.
All right, thank you. There's a question on particle sizes. Does particle size affect the spectra quality? And if so, what step can I take to reduce the impact of different particle sizing on the spectrum?
So the degree of impact of particle size really depends on how you are performing the measurement. If you are performing a transmission measurement, you'll see that some of the spectral bands may be flat-topped. This is a situation where the spectral band does not extend to 0% transmittance, and yet still appears as though the peak itself is actually saturated, where the absorbance maximum or transmittance minimum is actually flat. So to counteract the effect of particle size, then the general recommendation would be to prepare the sample by grinding, maybe with a mortar and pestle, maybe with a ball mill. There are a variety of means that can be used to reduce particle size.
All right. There's a question on, can you delete all the sample spectra and sample views all at once instead of doing it individually?
Yes, actually, so the small blue arrow, which is mentioned in the video, which dictates which spectra will be processed within the sample view, any of those which have the blue arrow next to it, when you're reviewing a sample view, those are the ones which will also be selected to be deleted from the sample view. So you have the ability to delete multiple spectra in one pass. Or if you click the sample view name itself from the Data Explorer at the left-hand side, you can delete the entire sample view. Now the software will prompt you to verify if that spectral data is not saved. It will prompt you to save it to make sure that you don't accidentally delete files which have otherwise gone unsaved.
All right, thank you. We have 10 more minutes remaining, so I'll try to get through most of the questions that are coming in. A question from Maria. Can you pull up a comparison that has been previously analyzed?
This, I guess, will depend on how the software is currently being used. So those, if you want to view the compare results within the standard Spectrum 10 software, when you open that Spectrum, the compare result is actually not saved with that individual Spectrum. But if you have the software set to record the compare results in the external CSV file, you can always access that result after the fact.
All right. There's another important question here. Can you comment on the chemometric capability included in the software? Are methods like PLS included as well?
Yeah, so the Spectrum 10 software, at least in recent years, has come standard with capabilities that we call Beer's Law Quant. Beer's Law Quant provides users with the ability to prepare quantitative methods based on peak height or peak area calculations. And that sort of approach is pretty useful in situations where the sample mixture may just be a two-component mixture, or where distinct spectral features can be picked out of the measured spectrum, which are associated with the parameter or compound of interest. For more elaborate quantitative methods, potentially working with natural products or very complex mixtures, then chemometric methods like partial least squares, which is PLS, would typically be employed. And PLS, as well as PCR and an algorithm that we call quant-C, these are available for the Spectrum 10 software as well. And then I guess the suitability for each algorithm really depends on the nature of work that is being performed with the FTIR and the nature of the available calibration samples.
All right. Amy has a question on our ES software. How can I improve the audit trails in the software?
I'm sorry, could you repeat that?
The question is on approving audit trail in the software.
Oh, okay. So to approve audit trails, I guess as a primary requirement, the user has to be set up, or I should say that login, that particular login has to be set up as an approver. Otherwise, if those permissions are not set, then there is no way to approve any of the results which appear in the software. As for details beyond there, that's probably worth email follow-up instead.
All right. There's a question. We were instructed to take a background before each sample. Is that an overkill?
That's kind of a loaded question. That's one that is posed quite often when I'm training customers. So it's not bad practice to regularly account for the intensity of infrared light going through the system, but the the situations where that practice actually becomes problematic is when users are not particularly careful about cleaning the ATR between measurements. So if a residue is left on the ATR crystal and a new background is measured, that can actually introduce spectral artifacts, kind of similar to what was shown in the video with the spectral peaks, which extended above 100%.
All right. There are a few questions on audit trails here. I think the basic theme that I gather here is there a way to disable the audit trail function in the software?
Disabling the audit trail function in the software sort of negates the purpose of the enhanced security software. So I don't see a situation where you would really want to actually disable that. Now, if the issue is more one of the number of signature points which appear in the software, the tasks which require user signatures can actually be customized within the software. But it's important to keep in mind that as those are eliminated, then you, I guess, reduce the number of possible steps in the measurement process where you can verify that the proper user is actually acquiring the data. But any changes that you make in the settings in the software should be done understanding the potential ramifications of that and how that may affect compliance in your particular setting.
All right. There's a question on calibration. If I have a calibration like oil and water, do I need to make this calibration every day?
You certainly don't need to rebuild a calibration every single day that you use the FTIR. That calibration file can be used essentially indefinitely so long as you have the file itself accessible and referenced in the software. But it is considered good practice to run a few validation samples on some sort of regular basis, perhaps daily, perhaps weekly, somewhere along those lines. So it's definitely overkill to rebuild the entire calibration, but it's worthwhile to just check the system and check your technique with validation samples to ensure that the measurement system is in good, clean condition, and also that your technique is sufficient to perform the measurement to your requirements.
All right. So Ryan, there's a follow-up to the 21 CFR compliance answer that we had. This is coming from Emily. How do you customize which signatures are required in the ES software?
So first off, the login in question, and this is kind of a common theme here too, to make changes to policy settings within the enhanced security software, you have to have appropriate permissions. If you don't have those permissions, then you aren't able to make those changes to policy. To access the settings for the signature points, you have the ability to make those changes within the administration menu. So if you go up to the top of the software, there should be a setup drop-down menu. So when you click that, one of the top items should be administration. And then from there, I don't remember the particular steps in the drop-down menu, but I believe it's the same menu that you use to change the groups. You can change group permissions as well. And the
Yeah. All right, and there are check boxes where you can check what to activate or not. All right, you mentioned baseline normalization in one of the slides describing the macro functions. How can this normalization be accessed to the software interface?
So that the baseline correction process you would find under the process drop-down menu, and there are three options available there for baseline correction. One is data tune-up, which, as I mentioned before, is kind of like a data beautification process, kind of a black box correction. Then there is a baseline correction process, which will automatically make a determination of baseline points to use for correction. And then the iBaseline process, which is interactive baseline correction. That allows users to manually view and specify points for baseline correction to verify that they have selected points across the spectrum which don't overlap with regions of interest or peaks of interest.
Great. In the interest of time, we'll take 2 more questions here and then we'll wrap up.
Sure.
In standard software, is it possible to lock your user folder so that nobody can touch it?
That may actually be done in the Windows operating system rather than in the Spectrum 10 software. That is probably worth contacting your local, your IT support to determine how to do that. But it's also important to remember that if you're talking about a directory which will receive the spectral data files, that the Spectrum software still needs to retain the ability to write files to that location. Otherwise, you'll have bigger problems.
Right. We'll take a question here, and there are actually a couple of questions, a couple of users have sent us. Can you comment on the ability of software to do multi-component analysis?
Yeah, so the way in which the components, I guess that's a fairly broad question. So there are library search methods which can be used to attempt to identify multiple materials in a sample. So the assumption there is that the sample which is being searched has more than one component in it, and the algorithm, which we call multi-search, can combine automatically library spectra to attempt to fit what is then assumed to be a multi-component spectrum. That can attempt to fit an unknown spectrum with as many as 10 library spectra, which of course will increase the processing time a little bit. And also it reports a sort of scaling factor, which is a pseudo quantitative or ballpark quantitative indicator, but should not be taken as a genuine, precise quantitative measurement. From there, then, in terms of quantitative analysis for multi-component systems, then PLS or PCR is probably most commonly employed. And to quantify the different components which are present in a material, first off, requires the availability of appropriate standards. So the FTIR, like any other instrument, if you want the system to perform precise quantitative measurements for your samples, it has to be calibrated. Without calibration standards, it's like someone handing you a blank strip of wood and telling you to measure objects around your house. So those standards need to be measured with the FTIR, and then the spectral data can be imported into the Spectrum quant software, where it is then coupled with the reference values associated with the parameter or parameters of interest or compound concentrations. So these concentrations or parameters can come from other analytical techniques, maybe from an analytical balance, if these standards are prepared gravimetrically. If the standards are, let's say, like total acid number, total base number standards, then those are, the reference values are typically gained from an auto titrator. And also actually other analytical techniques can be used to calibrate the FTIR, like a GC. So if you have concentrations of components determined by a GC, you can also use those to calibrate the FTIR after you've measured the standards. It's also important to keep in mind the potential limitations of your sampling technique. So generally speaking, the ATR sampling accessory provides just a mild level of sensitivity, which typically extends to percent levels, maybe in an optimistic scenario, maybe to 0.1% level. Whereas transmission measurements with a transmission cell can offer a higher level of sensitivity, but then your ability to work in complex mixtures may be limited by saturation of spectral peaks due to the higher path length for the infrared light. So that's just a broad overview, very high level view of multi-component analysis.
Right, we're over time, but there are 2 things I see here that may be important for users. There's one on what is the difference between compare and search function in the software?
Certainly. So I have some customers who almost use those interchangeably, and there is actually some overlap in functionality there. So compare, generally speaking, is actually designed and intended for users to employ for verification of material identity. So this is a situation where, as an example, if I am a plastic injection molder, maybe I want to verify that I am still receiving polypropylene rather than polyethylene, polyethylene terephthalate, etc. So I would measure a spectrum of polypropylene and save it as a reference. And then to test the next lot, the next few incoming lots, or however many lots of material I have coming in, then when I measure the spectrum of that incoming lot, I would simply press compare, because I know that I need polypropylene coming in. And so it would be used for a routine material identification scenario where the material identity should be fairly predictable. Now, search, on the other hand, is kind of at the other end of the spectrum in terms of the intended use. Search is meant to be employed in situations where the identity of the sample material is completely unknown. It's more of a dragnet approach at, trying to identify material or material type when the identity is otherwise unknown. But the software actually allows users to build custom spectral libraries. And so you can sort of use the library search functionality also for raw material identification. So that's where that overlap kind of comes in the functionality.
All right, got it. There are a few more questions coming in, but we're definitely over time. So we will take this over email with you on a one-on-one basis. There are also some questions on whether the recording is going to be available. We will send out a copy of this webinar recording right after the webcast, together with some survey questions. And these questions, I really want, if you could answer those for us, that will help us improve our offerings going forward. So with that, I'd like to end the webcast here. Thank you, everybody, for taking time this Friday. If there is something that is needed, please contact your local PerkinElmer rep or PerkinElmer service engineer.